Howdy folks, Clint Rawls here. What I've got the gauge minder. It's going to be going on a high pressure control valve pressure controller as protection for the bourdon tube on the sensing line. I realize this camera, hopefully whenever I upload it, everything's flipped around. I don't know why, but in the camera view right now, everything is backwards. But I haven't been able to figure out how to fix that. So, carrying on. We have a 300-pound bourdon tube on the pressure controller. I've got this gauge minder set exactly to 300 pounds, or well, close to 300 pounds. So what you'll see is this digital gauge. It shows one place behind the decimal point. So as we're coming up, we'll get right here. Try and stop on 100. So right there, 101. You see the gauge dials. I mean, this is a certified gauge. Ooh, you can't see. It blocked that shadow. Right there is 200 psi. And as we go up, you can see there 300 psi. You see the big gauge stopped. Now this one's still climbing. Now this gauge doesn't matter. You can go. Something gave. I think the seal in this pump might have just went out, but anyhow, maybe it's air. You can see this gauge minder blocks it off. 300 psi. I'm already well above 1,000, almost 1,000. I don't know why it won't go to 1,000. Anyhow, oh, I see. I got a leak here. So, with that said, that's the calibration of the gauge minder. Hey everyone, Clint Rawls here, Delta Valves and Controls. What I've got here, I've got a 1-inch stainless 2500 Class D series. This valve is for Hatfield, and basically we're supplying it with 4,000 psi nitrogen going into a 1301F regulator into a 67 CFR. It tees from there. It supplies the 4150 pressure controller as well as a 3582 positioner. A little detail on this setup. I've got a dial indicator here that's showing the travel. It's on the feedback arm, so you can see that's closed. That's going open. I'll leave it right there for now. Here we have a gauge minder. Because the set pressure, this is going to act as a downstream regulator. It's fail open, so it's a direct acting downstream pressure regulator. It's going to have 4,000 psi upstream, and downstream they want to maintain 160 psi-A, so psi atmosphere. In Houston, Texas, 14.7 psi atmosphere. That basically equates to 145.3 psi-G. This gauge is reading the sensing line pressure that I'm putting in. So at 145.3 is where I want to touch the seat. Let me think. Anything else I need to go over? I don't believe so. So, right now, you can see I'm set just a little bit below 150 on the pressure adjustment dial. These aren't super accurate. You can, in this setting, it's calibrated to be extremely accurate from, let's say, 125 to 250. The more you turn the proportional band, down, so closer towards zero, the faster the valve will respond to the pressure change and the more it will respond. However, the closer you get to zero, the less accurate the calibration is. So as soon as you adjust this dial is going to be off. If the valve's reacting too fast and you want to slow the response times down, then you would back it, basically go, closer to 10 to proportion it properly. Particularly compressor stations where you're trying to maintain suction pressure between a high and a low range so the compressor doesn't kick out. It's operating too fast, you go closer to 10, or you tweak it the number up, the valve will respond slower. If it's operating too slow, then you basically turn the proportion down and the valve will operate faster. But right now, I've got this thing set to about 145 and a hair, which is whenever it touches the seat. So I'm gonna just look over here on the dial so you can see. I'm gonna come in real slow. I'm gonna stop right there. So you see we're basically at 144. Bam, we're at 145. I can't read a 0.3 on this gauge. It does have the fine hairs, but you're splitting hairs there. So now we're at 145. I'm back. Okay, so I start backing down at 144. I'm already beginning to open the valve if you're watching that dial. Back to 145. Now, that's just touching the seat. To get full actuator pressure load, so for tight shutoff, we got to be about 146 to 147. I'd say closer to 146. Yeah, right at 146 psi. That's pretty tight accuracy. So we're bleeding off. The valve should maybe bump open. I'm not sure. I might have to come off a tiny bit more. It's starting to crack barely off the seat. Right there. Spot on 100 and... Man, we're almost 145, but anyhow. Right there. Sorry. There we go. Yeah. It's a hair above 145. But basically, yeah, that's how it works. So this valve will begin throttling. Let's see. The mid-stroke position. About right there. In fact, it's probably specifically on that dial is 0. Right there. Close enough. Okay, so the mid-range position, we're at about 139 psi G. So that'll kind of tell you how this thing's operating. To adjust the pressure setting, you just basically have to turn that dial. I'm not going to touch it because I've got it exactly where I think it needs to be. When process pressure is applied to the line, this is an unbalanced plug, so it's going to have some resistance when moving, and especially whenever it goes into the seat. The actuator side is plenty capable enough to shut off against 4,000 psi, but 4,000 psi is a lot, so you're going to see that positioner The reason we have it is because it's going to sense it like a cruise control, and no matter what process fights back on that plug, that positioner is just going to apply more pressure to put it where the controller is telling it needs to be. But all in all, should work beautifully. I have calibrated this pneumatically, so on air, as well on nitrogen. And I can tell you 100%, I calibrated it on air, hooked it up with nitrogen, absolutely no change that's noticeable. I was actually very surprised. I thought there would be quite a bit of change, or a noticeable change, but realistically there was none. Anyhow, that concludes my video. This is strictly for you, Hatfield. Appreciate the order, and we'll get it crated up, get it out to you. Thanks.